Okay, so thank you for having me. I'm really glad to be here, especially because I get to meet some of my colleagues that I only work with on the internet usually, so this is great. So today I'm going to talk about data mining cuneiform texts, but some of the principles I'm going to discuss can also be reapplied to other types of data, but my examples are all based on textual data. Sorry. Oh, sorry for the font. Okay, that's the... I work... Okay. So before diving into the talk, I'd like to define what data mining is in this context. So the idea is to create new knowledge by extracting information from data. So you don't necessarily need fancy machine learning algorithms to mine some data, but this cannot be done using traditional approaches to text. You need to process the text in a way or another. So this falls into the realm of quantitative analysis, but you can also reapply some qualitative analysis afterwards. So those of you who are in archaeology probably use some quantitative methods daily, but it's still a novelty for some of us, for most of us in text analysis, especially for ancient languages or low resource languages. But we're very lucky because there are many DH centers and labs and associations that are popping all around to help us with this. So they support digital and data-driven inquiries into humanities topics. So today I'm going to discuss methodology. We're going to talk about a way to work with textual data, but also metadata derived from the analysis of cuneiform objects. So I'm going to try to bring us from raw data, so the actual transliteration of the text, up to visualization of data that was extracted from there. Sorry. So the mining component in this process is the harvesting of co-occurrences of entities in the text. The example that I'm going to give later on is we're going to look at the ego network of an individual that lived in the city of Arab in southern Mesopotamia in the old Akkadian period. But I'll give you more detail on that later. I just want to put emphasis on the fact that when we work with raw data, so with transliterations that are not annotated or anything, it's really hard to interact with that data and to extract some meaningful information from it, especially if you have lots of it. So when you refine this data, then there's a world of possibilities that opens up to study those texts. So the first step really is standardization. So meaning that using the same conventions throughout the corpus and avoid variation when possible. Because if the data isn't standardized, then it absolutely needs to be pre-processed or you won't be able to work with it. So it's a prerequisite, then it just won't fit in your algorithms. So when the data is standardized, then you can start applying computational methods to process the text and extract information from it. So starting from raw data, so annotated text, for example, from the CDLI database, one task that we can do is to parse that text to tokenize it, which is really just a fancy word meaning to separate the string that is the text into smaller units, words. Today I'm not going to discuss identification of affixes, so smaller units around the words or sentences. Because my sample, the data I'm working with, is really short administrative texts. So for me, that's a meaningful unit. I don't need to go into smaller units. Usually there's only one transaction per text. So the text is thus parsed using a tokenizer algorithm, which then creates a substrat that must be stored. So it can be stored using annotations or a database or spreadsheets or other means of storing data. I use a means that I don't use annotation because I want to keep the text clean to be able to interoperate with the CDLI database easily. It's still possible to remove annotations from text, but that was a solution for me to be able to foster this interoperability. The font is really weird. Okay, so this is an example of a transliteration directly taken from the CDLI. If you tokenize that text, then you can extract the vocabulary that was in the text. And then from those tokens, you can extract words or lemma that are like dictionary entries, if you like, of those words. And then you can associate all of these together. To extract this information, it's really easy, in fact. So at the bottom, you can see that's just 3 little lines of code that is the core of the way to tokenize a text. It's extremely simple. We do that using regular expressions, and those are available in, I think, almost all programming languages. You can even use advanced text editors that will permit you to use regex into them, so like the new Atom, but it's really hard to load larger files, but anyways. So you have to find, depending on your data, you can work this out. So what do we do with this extracted data? Where do we put it if we don't annotate the text? And what about the association between the text and then the tokens and the lemma? For those who know Debase, that looks fine. For those who don't know Debase, don't be afraid. There's only about 3 or 4 tables in there that manage vocabulary. So this is all the data I collect. I even have more tables now because I'm taking into account some physical aspects of tablets. But only about 3 or 4 tables there are used to manage vocabulary. So what is great about a relational database like this one is that you have basic tables that they're basically like spreadsheets, right? But then you have other tables that are used to map the relationship between those tables. So then you can leverage these relationships and further along. So I tried to put this in another way to make it maybe more clear. So you have entities. So you have information about entities stored in some tables, and then you have other tables that store information about the relationship between these entities. So then I would also have a tablet table in the entities section. So the way to do this is by giving a unique ID to entities and then referring those in the relational tables. So we can store information about the text, but we can also store information about we can also store other information that pertains to the context, for example, the period or the place where the text was found. And then we can put all of these things in relation later to study different questions. So reasons why it's a good thing to use quantitative approach on refined text data is that you can leverage the structure you put into this data, and then you can navigate or reuse this information more easily. I'm going to show an example after. You can also use this information for stat analysis, like Vanessa Julie's work. And you can also verify some hypothesis based on impressions or parts of corpus, and you can reapply it to your whole corpus using stats. So, just a second. Where is it? Here. Okay, so Arab is a city in the south center of Mesopotamia. My research focuses on the 3rd millennium. So I'm only studying the text from the 3rd millennium. It's about 2,700 texts. The DUG was done by the Chicago Oriental Institute, but the texts that come from Arab come from various collections. And this is where I have to tell you, as per ASOR's regulation, that I'm not using only the text from Chicago. I also use the text from all the other collections. And I'm not going to talk today about the texts that are unpublished. from these other collections. Other collections include the texts in Istanbul that are kind of inaccessible right now. Of course, there's some at DOI. Then there's Yale, the Free Library in Philly, the Scan Collection, and also, of course, the Rosen Collection in Cornell. For my work, I use CDLI scans and pictures that were graciously given to me by Cornell. And I'm planning a little visit to look at some of the texts I'm unsure about based on the pictures. So for my example, I did a little Twitter survey. I think some of you might have helped me decide who I was looking at today. So we decided to look at the network of Or Ninsun. This person is attested in texts that are from the Central Archive in the Kitchen group. And most of the texts are related to sheep and breeding. So first, I have a research database that I use. I create views to see the correlation between different elements in the database. And so these views can be created depending on what are your needs to view this data. So this one is, I use Cake PHP as a framework, but you could use Drupal, for example, or maybe even Omeka. So any CMS that can manage relational databases, you can leverage the tools that are in place there to create views to match your data. So that's one of the reasons why relational data can be really useful, because then you can display that data in different types of views easily. But we can go one step further. And we were lucky we already had a little information about graph data earlier in some of the talks. So what is really interesting about graph data is that it focuses on relationships and not only on the entities. So if we're able to harvest our data and transfer it into graph data, then we're able to view these relationships more easily and find patterns, even visually, before applying any sorts of complicated stats analysis. So based on the Or Ninsun network, I was looking at people that occur on the same tablets as him, and then as the people that occur on the same tablets of people that he has in his own network. So I extracted the data from that, and we get about information from 40 tablets and co-occurrences of people of about 300. So these are MySQL queries. So to extract that data, you just need to write a little query. It took me a long time to write those, but if you ask someone that is good in databases, it'll take them minutes. They'll just type this up for you and extract your data. It's really easy, in fact, for them. So first you need to extract nodes, so entities that you're interested in, and then you need to extract edges, so how do these people relate to each other? And then you need to run permutations to see, because so from the database you have, thank you, the co-occurrence of an entity and then a tablet, so then you have to create the permutation to know between each of these people, create those relationships. So when you have this data ready, you can use a graph visualization software to view that data. So here I'm using a force-directed layout. I haven't applied other methods on it yet. So this is Or Ninsun right here. So we can see that he's a hub between two different groups. And it also reveals that one of his close collaborators, or someone that occurs often on the text as him, is also a hub between two different groups. So then this can help me decide where I should look to understand this person better. So maybe I should compare text from both groups and then see, do they talk about different types of goods? Or so are there two different circles of influence in which he's influential? Okay, so one other great thing about graph data, again, I think we all agree, most of us, those that smile right now, agree with me, that the way to go to share data is linked open data. For text, we're really lucky because there's a whole set of ontologies for linguistic data. So by using a relational database, you can extract graph data and share this data using linked open data. And then the next talk is going to focus more on linked open data, so I'm not going to talk too much about that. And I'm going to end here because I'm out of time. This is big data, and this is our algorithms when there's too many texts. There. Thank you.